Are we together?
Yes.
Right. So, in the other case, we said what? Acceleration, force, restoring, force. Now we are dealing with moments. Acceleration, moment, is equal to restoring, moment. It's the same thing, but now interpreted for moments, because there is rotation now. Are we together?
Yes.
Right. Now let's look at our accelerating items. Accelerating items are simply inertia items, things with mass. In this case, what we have with mass, this block, a 10 kg block. Are we together? I think I didn't put a note to say people can come. Nothing is happening.
No, I am. Somtshela ukuthi ayiphosa akusona yakhe akayifake lapho uyagera
Did you pass the books around? Just have a look. Just pass them around. Right. So we now want to model this thing. And for us to model, now the moment you are dealing with a system which is a number of motions, I always say, I tell you what the books don't tell you. Ne? Let's start by our constraints. Always start by doing your constraints. And what are you looking at? You are looking at the different motions and trying to tie them up together. Your books don't tell you that. They don't like you like me. Me, I like you. So I tell you some of these things. But the people that write books, they don't like you. Right. Let's identify the motions. One, we have, this thing will be rotating about the pivot like that, ne? Let's call that theta. That's our first motion. Hey. I want to sneeze. Hey. almost coming and then stopping. Just you know what it does. Let's call the motion at the end here for this thing. Let's call that x. As this thing is doing this, this bulb is this mass is going to move by x at the time when this describes theta. And then this is another point where there is motion. Eh?
Yes.
So let's call this one x1. So we have how many motions? The bar itself, theta. Then we have this block. Let me call this for a reason. Let me call this one x and this one x1.